Yep, so we're continuing with binomial random variables, the binomial distribution. We have a situation. A 10-sided die is rolled 5 times. Determine the probability of getting 110. Have you ever heard of a 10-sided die? 10-sided die? Yeah, they do exist. They're called deltahedrons, deltahedron dies. You got 10-sided dies, 12-sided dies, and 20-sided dies. We're taking one of these suckers, and we're rolling it 5 times. 5 times. And we're interested in getting 110. So success means getting a 10, right? Success. Is 10. So failure would be not 10, right? So failure is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now what's x? X is your number of successes, right? It's your number of 10s that you would get. Number of 10s. So we want x here to be 1, right? We're interested in getting exactly 110. Exactly 110. Now what's the number of trials? The number of trials here, 5, right? 5 trials. We're rolling our die 5 times. So 1, 2, 3, 4, 5. Every time we roll a die, it's a trial. And the probability of success on a single trial, so you roll your die 1 time. We're not told what it is, but I mean, we know you have 1 way to get a 10, right, out of 10 different numbers. So 1 in 10 is your chance of getting exactly 10 on a single roll, So that's 0.1, right, as a decimal. Now, we're interested in getting exactly 110 on 5 rolls. 5 rolls, right? So I'm looking for the probability that the number of 10s is equal to 1. The probability of getting exactly 1 10. So what I'm going to do, I'm going to go in my table. I'm going to look at n is 5. Then I'm going to look up p is 0.1 and look up x equals 1. That's probably the best way to do it. So I'm going to go in my table. So I'm in my binomial distribution table. Now notice here that n is here, right? We're going to look up n equals 5, right? There are 5 trials, 5 rolls of this die. And the little p, probability of success on a single trial, when we roll the die just once, is 0.1, right? 1 in 10. And we're interested in getting exactly 1 success, 110. So we're going to put this together here and here, and we're going to get our probability, 0.328. Okay, and click off that. There we go. There it goes. Roughly a 32.8% chance. If you wanted a percentage, 32.8% chance of getting exactly 110. Well, we write them as decimals most of the time, 0.328. Okay, number 2. Same situation. You got a 10-sided die that you're rolling how many times? 5 times. What's the probability of getting the following? 4 10s. Okay. So again, x is the number of 10s we're interested in getting. So we want x to be 4, right? We know there are a total of 5 trials, right? We're rolling the die, that 10-sided die, 5 different times. And we know the probability of success, the probability of getting just a single 10 on a single roll of the die is 1 in 10, right? A 1 in 10 chance, 0.1. Okay, so I want the probability of the number of 10s being equal to 4, right? I want 4 10s. So what I'm going to do, I'm going to go to my table. I'm going to look up n equals 5. Little p is 0.1 and x equals 4. So let's do that. So back to my table. Erase this stuff. And start from the beginning. So you know how to do it. Okay, so n equals 5. That's the number of trials. Little p was 0.1. And we want x to be 4 successes, right? We want exactly 4. 4 10s. 4 successes. So you see that 0.000? That's a really small probability. So it's so small, it's essentially 0. So small. So small. It's such a tiny probability, it's essentially 0. So we'll just write 0.000. So it means it's very, very, very unlikely. So, I mean, actually, they just rounded off the 3 decimal places. Probably if you went out to 5 or 6 decimal places, it would be something. But it's such a small probability that they didn't even bother writing it because they only go to 3 decimal places. So very small probability. Okay. Number 3. What is the probability of getting... less than 3. Less than 3. Let me write it out in words. Tens. Okay, so the situation, I'm rolling my die 5 times. What's the probability I'm going to get less than 3 tens? So remember, x is the number of tens. So we want our x to be smaller than 3. Of course, we have 5 trials, right? You're rolling this die 5 times, and your probability of success on just a single roll is going to be 1 in 10, 0.1. So think about this for a second. If you have less than 3, so the probability of getting x less than 3, number of tens less than 3, you could have 0, right? 0 tens. You could have 1 10, or you could have 2 tens. So I'm going to look at the probabilities that are x are 0, probabilities that x are 1, probabilities that x are 2, and we're going to add those probabilities together. Okay, so I'm going to go to my table. I'm going to look up n equals 5. I'm going to look up little p is 0.1. I'm going to look up x equals 0, 1, and 2. Let's do that. They're doing a little erasing here. Okay, so first n equals 5, right? Well, supposed to. There it goes. Then little p equals 0.1. Then x equals 0. Here's x equals 0, 1, and 2. Here, here, and here. So we're going to take those 3 probabilities. That's x equals 0, x equals 1, x equals 2's probabilities. And we're going to add them together. Let me write those down so I don't forget them. My memory is like a fish. I can't remember much at all. Okay, so I wrote them down. I'm going to go back to the screen. For 0 tens, the probability was 0.590. For 1 10, the probability was 0.328. Hey, that looks familiar, right? We just did that one earlier. Yeah, 0.328. That was the very first one. And for the probability of getting 2 tens, that was, what was that, 0.073. So when I add those 3 numbers together, what do I get? 0.590 plus 0.328 plus 0.073, 0.991. So roughly 99% chance of that happening. Okay. Less than 3 tens. 4. At least. What's the probability of getting at least 2 tens? Good question, right? At least 2 tens. At least 2 tens. Okay, so remember x represents the number of tens, right? You're interested in getting 10. So the number of successes, number of tens. You want your x to be at least 2. What does that mean? At least means it's greater than or equal to 2, right? You want x to be greater than or equal to 2. Okay, now n is the number of trials, right? We're still rolling these, we're still rolling this die 5 times, so there's still 5 trials. And your probability of success on a single trial, just rolling it 1 time, is still 1 in 10. 1 in 10, which is 0.1. So I'm going to write this as the probability of x greater than or equal to 2, right? We want to find the probability of getting at least 2 tens. So x greater than or equal to 2. If you think about that, that could be 2. So you could get the probability of x equals 2 plus the probability of x equals 3 plus the probability x equals 4 plus the probability x equals 5, right? If you have at least 2 tens, that means you can have 2, 3, 4, or 5. Total of 5 could be the maximum, right? It's the maximum you can have because there are only 5 rows. All right, so we're going to go in our table. We're going to look up n is 5. We're going to look up p is 0.1. And we're going to look up x is 2, 3, 4, and 5. So let's do that in our tables. Where is that? Right here. Scratching everything out. So starting with the n, that's the number of trials. It's the number of rolls. 5 rolls, right? P, 0.1, right? You have a 1 in 10 chance of getting a 10 on a single roll. And then we're looking up 2, 3, 4, and 5. X equals 2, 3, 4, 5. Okay, you get these numbers. 0.073, 0.008, and then the rest are 0. What was that? Okay, I got to get off this. There it goes. 0.073, 0.008, and the rest are 0. 0.073 plus 0.008, and the rest are 0. I think that's right. Let me go back and just double check. My memory is like a fish memory. Yeah. So I have these numbers up, and I should get 0.081. Okay, so let's do one more. Number 5. No tens. What's the probability of getting no tens? No tens. Remember, x is the number of tens. That's what that represents. It's the number of successes. Success means you get a 10. And you want your x to be 0, right? You want to get 0. So this right here, this word no right here, that means 0. No tens. Now remember the number of trials is 5, right? You're still tossing this die or rolling this die 5 times. The probability of success on a single trial, if you just roll it once, is still going to be 1 in 10, 0.1. So what I'm going to do, I'm going to go in my table. All right, let's write this down. The probability that x equals 0, right? Probability of the number of tens being 0. We don't want any tens. I'm going to go in my table, and I'm going to look up n is 5. I'm going to look up p is 0.1, and I'm going to look up x is 0. Let's do that. Where is it? Right there. So here we go. N is 5. P is 0.1. X is exactly 0. .590. Which I think we probably looked up somewhere in the past. Did we? Somewhere? Yeah, we looked it up when we were looking x is less than 3. All right, so roughly a 59% of getting no tens, 0 tens.